Welcome back, Focus Learners, to this explainer. Okay, I am so incredibly thrilled to have you here today because we are looking ahead to a truly spectacular night sky event. You are going to want to mark your calendars right now for the night of August 27th into the early hours of August 28th, 2026. We are in for an absolute astronomical festival. For several hours, the moon is going to fundamentally change its appearance, turning this deep, dusky red. It's almost like someone took a sunset filter and just dragged it across the entire night sky. If you are even remotely curious about space, this is exactly the kind of evening that is totally worth stepping outside for. Deep eclipses like this one just don't happen every year, and it is a really long wait for the next one. So we're going to break down exactly what you'll see, why it happens, and how to get the absolute most out of it.
Okay, let's dive into this. We've got 5 main parts to our journey today. First, we'll look at why this is a rare cosmic spectacle. Second, why the moon actually turns red. Third, the mechanics of eclipses. Fourth, asteroids and ancient names. And finally, number 5, how to view and photograph the event.
All right, part 1, a rare cosmic spectacle. Not your average eclipse.
Now you might be thinking, hey, I've seen an eclipse before. What's the big deal here? Well, this is definitely not your average run-of-the-mill lunar event. We are looking at a deeply unusual astronomical occurrence that absolutely warrants some serious FOMO if you miss it. Normally, when we talk about a partial lunar eclipse, we're usually looking at the Earth's shadow covering somewhere between, say, a quarter and half of the lunar disk, so roughly 25 to 50% coverage. But look at this August 2026 event. We are hitting a staggering 96% coverage. Hitting a depth of 96% is genuinely exceptional. It's not routine at all. Earth's shadow is going to swallow up the overwhelming majority of the moon.
So what is the actual difference between a total eclipse and the deep partial eclipse we're going to see? Well, technically speaking, during a total eclipse, the whole moon sits entirely inside the darkest part of Earth's shadow. But during this 96% deep partial eclipse, a tiny, practically microscopic sliver of the disk stays just slightly outside that darkest shadow. But practically speaking, for you and me just standing in our backyards, the spectacle is going to be almost visually indistinguishable from a real total eclipse. Except for that super thin sliver at the very edge staying slightly brighter, your naked eye really won't be able to tell them apart. Formal partial label aside, it is going to be one of the most visually striking events of the entire year.
Moving right along to part 2, why the moon turns red. The cosmic filter.
This brings us to that famous blood moon aesthetic. I want you to think about this question for a second. If the Earth is moving directly between the sun and the moon, effectively blocking the light, why doesn't the moon just go pitch black? Why doesn't it completely disappear into the night sky? I mean, it's sitting right inside Earth's shadow after all. But it doesn't end up in complete darkness.
The answer is literally right above our heads. It's our atmosphere. The moon actually keeps receiving light, but it's light that has grazed sideways right through Earth's atmosphere. You can think of our atmosphere as a giant, incredibly efficient cosmic filter. It scatters all the shorter wavelengths, the blues and the violets, away, but it lets the longer wavelengths, the reds and the oranges, pass through almost unhindered. And then, that red light actually gets bent toward the moon, lighting up its surface in that iconic deep red glow.
It's so fascinating that astronomers actually have a dedicated system for rating just how dark and saturated the moon gets. It's called the Danjon scale. It was proposed by a French astronomer back in the mid-20th century, and it runs from a 0 to a 4. A 0 means an almost invisible, cold, dark moon. A 4 means an incredibly bright, richly coppery or orange moon. And here's the wild part. The score depends entirely on the exact state of Earth's atmosphere on that specific night. If the atmosphere is super clean, you get bright copper. If there's a lot of smoke, dust, or, say, volcanic ash hanging around, the moon appears much darker and gloomier. So if you manage to see multiple lunar eclipses in your lifetime, you will literally never see the exact same shade of red twice.
All right, let's zoom out for part 3, the mechanics of eclipses, orbital geometry.
Okay. So you might be wondering, why doesn't this happen every single time there's a full moon? Well, the secret lies in a 5-degree tilt. The moon's orbit around Earth is not perfectly flat compared to us. It's actually tilted by about 5 degrees relative to Earth's orbit around the sun. Because of this slight tilt, during almost all of our full moons, the moon passes just a little bit above or just a little bit below Earth's shadow, missing it entirely.
So, an eclipse isn't just some monthly routine. It requires the sun, the Earth, and the moon to line up absolutely perfectly across millions of years of complex orbital motion. Only a couple of times a year do all 3 bodies align precisely enough for that shadow to actually sweep across the lunar disk. It is a genuine, beautiful, incredibly rare coincidence of geometry.
This brings us to part 4, Asteroids and Ancient Names, the full festival.
Beyond the heavy orbital physics, this event has some really rich cultural context. Have you ever wondered where names like Sturgeon Moon actually come from? This tradition originated largely with the indigenous peoples of North America, and it was later adopted by farmers' almanacs to track agricultural and hunting seasons. Pretty much every month has a historical name. January has the Wolf Moon, or sometimes they call it the Frost Moon. October, you probably know, has the Harvest Moon, and this August full moon is the Sturgeon Moon. It was named specifically by people living around the Great Lakes because this was the exact time of year when massive lake sturgeon were most readily caught.
But listen, the moon is not acting alone on August 28th. We have to talk about asteroid 9 Metis. Discovered way back in the mid-19th century, this is one of the largest asteroids in the main belt between Mars and Jupiter. It is so large and so regular in shape that it can sometimes literally be mistaken for a miniature planet. And on August 28th, it will be at what astronomers call opposition. Now, asteroids pass through these orbital points regularly, sure, but this specific instance lines up neatly with our deep partial eclipse. It's an entire series of celestial events converging all at once. Like I said, a total astronomical festival.
Which brings us to our final section, Part 5, How to View and Photograph, Practical Tips.
All right, so how do you actually view and capture this thing? First up, let's look at the timeline. This is not a blink-and-you-miss-it event. The eclipse lasts for more than 5 hours from start to finish. Now, if you live in North or South America, you've got the prime seats. The maximum eclipse will happen during a super conveniently dark stretch of the night. But if you're watching from Europe or Africa, take note. The moon is going to be pretty low on the horizon and close to setting during the peak. So you will absolutely need to find an open view of the horizon totally free of tall buildings or trees to catch the best part. And you can always just fire up any astronomy app on your phone to get the exact local start and peak times for your specific city.
So the crucial point here is how to photograph this without it looking terrible. If you just point your phone and use the automatic mode, your camera is going to try to overcompensate for the dark sky, making the shot way too bright, and the moon will just look like this blown-out white blob with zero detail. We've all been there. Instead, just follow a few simple steps. Number 1, manually lower the exposure right in your camera app. Number 2, tap and lock your focus specifically on the moon, not the sky around it. And number 3, use a tripod or a stable surface. Seriously, even if you think your hands are steady, they will shake noticeably at that level of zoom.
Finally, here is your quick viewing checklist. The great news is that you absolutely do not need a telescope for this. The naked eye is perfectly fine. Though, if you happen to have some binoculars lying around, they will for sure help you make out stunning lunar details under that unusual red lighting. Make sure you plan ahead with warm clothing since you might be out there for a few hours. And honestly, most importantly, get away from bright city lights. City light pollution can completely wash out the already dim reddish glow of the eclipsed moon, so find yourself a nice dark spot.
I want to leave you with this deeply poetic thought from our source material to sit with while you're out there stargazing. When you look up at that blood moon, you are looking at the reflected light of every sunset and sunrise happening on Earth at that exact moment. Think about that. All the sunsets and sunrises of the world projected onto the lunar surface and reflecting right back into your eyes. It is just an incredibly profound way to connect with the cosmos. And it really makes you wonder, what other incredible secrets of the universe are hiding in plain sight, just waiting for the perfect alignment of geometry for us to finally notice them? Thank you so much for joining me on this explainer, Focus Learners, and clear skies to you all.